So thank you everyone for joining us on the BrainX Community Live November 2021 event, which is another very exciting event. We have some very special speakers. We have a theme which is very close to the heart of many of the clinicians who are at the cutting edge of AI in healthcare application, trying to define and trying to redefine it. And there is a lot of experience today amongst the panelists and other people who are joining us, which can be shared. For those of you who are joining for the first time, the BrainX community was formed with the idea of machine learning and healthcare for good. We have had 3+ successful years, 3,000+ international member community, very active. The LinkedIn community is about to cross 2,000 members. We just redid our webpage that I'll showcase. As I mentioned, the group on LinkedIn is called BrainX Community 2, which is the active part of our community, a lot of exchange of scientific material over there. And then we do these monthly live sessions. And on the picture that you can see on the right is where we started locally. Of course, we went virtual, but we did go virtual before the COVID pandemic hit because of the demand from our international members. This is how we have redone our webpage, where you can find all the resources and the material that is available to you at your fingertips. The homepage with your updates section, so the latest and the greatest is linked over here, and you can find that. We have the connect session where we house either the upcoming live events or information related to them, or the past events, and link to the YouTube video channel, so that if you miss the live event, you can go and view it over there. And of course, we have our own BrainX Community YouTube channel where all these events are posted, so you can view them at your leisure. As I mentioned, an active LinkedIn group. We do have the Learn section, which has a list of curated articles which are linked, so you can go to the article website or the journal website that is available to us. And these are categorized based on different specialties, so that you can either do a focus review for the specialty of your interest or look at other specialties and gain from learning. And we did add the filter option recently so that you can filter it based on your needs. Again, it could be based on the time frame, or it could be based on the specialty that you're looking for. And we do have the journals, so you can filter it for journals. Some of the top journals which are focused specifically for AI in healthcare, and books. And very proud to have our 2 featured authors. Their books are listed on this page. Both Dr. Anthony Chang and Dr. Hoyt's book, highly recommended. So please go to this and check out those books. They are listed on this page. And of course, the popular data section, everybody's looking for data. And this is one of the largest repository of links to open source data sets. And again, you can filter it by different specialties. You can find these open source data set links directly going from here and fulfill your data needs. And I think Dr. Hoyt is going to talk more about it and how you can curate that data and certain tools later today. And earlier in the year, we started our podcast series, a very successful series. And we're looking forward to having Dr. Anthony Chang and Dr. Hoyt and many others featured on this in the next few sessions. So listen to some of the experts, listen to their journeys, listen to what they are looking to do in the future. So please subscribe us. It's called BrainX Talks, available through various mediums that you prefer for your podcast. Meetings and conferences, of course, the ABAIM 2022, which is going to be the global summit coming up in California. In person, again, highly encourage you to look at that, register for that, so that we can all connect and meet over there in person. That is what got me started with my journey for AI in healthcare. So something that is always featured over there. And other organizational meetings like ABAIM and the Medical Intelligence Society, they're all listed over there. So take a moment to go over there, look at the meetings that you would want to be at, and gain from the networking opportunities, from the learning opportunities presented over there. Gonna get started. Few featured speakers: Dr. Anthony Chang, Dr. Hoyt, Dr. John Lee, and Dr. Nyugen. So we'll start with Dr. Chang, followed by Dr. Hoyt's presentations on training clinicians to implement AI in healthcare, and then we will engage Dr. John Lee and Dr. Nyugen to give their thoughts and have a good discussion. So with that, I'm going to transition over to Dr. Chang, and I'm going to invite him to present his talk. And of course, Dr. Chang, I don't think I can do justice to his introduction, but he's the one who has been a great mentor, a great friend, somebody who got me started in this journey a long time ago now, been 4 or 5 years, have been there at all the AI Med meetings and the events. He's the founder and the driver of a lot of AI and healthcare organizations, I should say now, including MIS, ABAIM, that we'll hear about. He, of course, in his clinical work is a pediatric cardiologist and intensivist. He's also the Chief Intelligence and Innovation Officer at Chalk's Children in Orange County, and he's the chair of ABAIM. Of course, the author of some of the awesome books and the editor of the Journal for Medical Intelligence. I'm going to hand it over to Dr. Anthony Chang.
Thank you so much, Piyush, for your friendship and your support. And I guess 5 years is a long time in AI medicine time. So Piyush asked me to put some slides together and make some comments about medical education at all levels. So I think we should always just, pay tribute to all the frontline clinicians, and including an estimated 25,000 we've lost around the world. That's an incredible number of doctors, nurses, and respiratory therapists. And just to give you a very quick update on what's happening in artificial intelligence, again, I think it's more like a tsunami, the very fast rising water level, and not the tidal wave that people think it is, because it's already here in many different forms. And just to give an example, there's a lot of discussion about using real world data. I just gave a talk a couple of weeks ago at the FDA about using multimodal AI for their medical device follow-ups. And it's no longer just randomized controlled trial data. Another area that's fast developing is the concept of collective learning and collective intelligence. Our hospital is teaming up with Stanford to put together a dyad of AI capability for data sharing in the form of an edge node. So it's essentially the beginning of federated and even swarm learning. So federated learning is a concept that, as clinicians, is sort of music to our ears, because that's a way of sharing insights without necessarily sharing raw data. So as good as it sounds, hopefully it will deliver. Another big area that's also becoming a major factor in what we do and the excitement for AI is the concept of pushing AI peripherally, like a peripheral nervous system. So a lot of the embedded devices this decade and next will actually have primitive neural nets embedded in, so that we don't have to push everything to the cloud all the time. And also, I think I'm very excited about an area that our team is getting involved in, is the concept of digital or virtual twins to as a paradigm shift for clinical research, especially for rare disease patients or unusual patients. So there's a lot of, I think, developments in the area that's even peripheral to artificial intelligence will be quite exciting. And that's why we all need to really, I think, learn the basic concepts of artificial intelligence. The bottom line is we want to deliver precision medicine at the individual level, and then population health for the entire population. So having said that, I guess you're here because you don't need further justification to learn about AI. So my personal journey started with, well, I've always liked math, but also with Dr. Bill Norwood, my mentor, who's a heart surgeon. Here's a picture of me visiting him prior to him passing later that year. But he was a PhD in physics and complex math. So he got me very involved in chaos theory, even in my fellowship training. So I've always enjoyed finding signals in the noise. So if we look at what do we need to do to educate all of us in artificial intelligence and medicine, this is the recent updated estimated number of students, medical students, trainees, and clinicians we have in this country. I guess judging from the pandemic numbers, things are going to fluctuate. There'll be more students and trainees, but less clinicians as a result of the pandemic. But having said that, if we look at how are we going to educate everyone, there are sort of three categories I'm putting into. One is what I call real world AI resources. So that's the meetings, the courses, videos that you can find, even AI in healthcare now, and then books and articles. And articles are exponentially increasing in number, as you know, in different subspecialties. So that's how you can get your education, is just putting together your personalized portfolio of these tools. And those of us in the Medical Intelligence Society, as well as ABAIM and even ABAIM Med, will make strong recommendations for certain books and articles. So you definitely have people with available lists instead of trying to search it on your own entirely. There's also certificate programs. The American Board of AI Medicine that I co-founded with Dr. Hoyt, with the support of others, including ones that faculty that you see here, was one of the first, if not the first, that's clinician driven. And then there are other now certificate programs under different schools. One of the philosophies of the American Board of AI Medicine is to not make it a specific university as the owner, and we have many sort of contributors and multidisciplinary faculty. So, but there are certainly increasing number of certificates that you can get in AI or machine learning in healthcare. And then lastly, there's the option of degree programs, particularly master's or PhD level degrees. So I've sort of put the students and trainees a little bit as higher bubbles, because I think they're usually in a better position to pursue the advanced degree programs. And then I think the bulk of the clinicians, especially the senior clinicians, may be a little bit averse to going back to school like I did, and will probably prefer either a real world resource as an education or a certificate program. So I think perhaps the trainees and the students will be a little bit more motivated and perhaps in a better position to go to a multi-year advanced degree program. So in terms of real world AI resources, as Piyush mentioned, there's the Medical Intelligence Society. We're very active with a monthly meeting and an annual summit that's well attended. There's BrainX, of course, that you're part of. And also AI Med has Clinician series now virtually, as well as the Global Summit every year. We range, this year will be uncertain, but previous years we've ranged 500 to 700 attendees with about 50 speakers usually from about 25 countries. So it's a very exciting meeting given the attendees that come, all with a passion to disseminate AI in healthcare. Now, these are some of the courses and videos that are available for those of you who are interested in getting further education. I highly recommend, not just because I'm an alumnus, but the Stanford AI and Healthcare video series with a capstone course. So that's something that Matt Lundgren and his colleagues have put together. It's actually quite good. It's very complementary to the ABIM course. And then two series that I found to be particularly helpful to spare you many hours of looking through bad video clips. One is StatQuest. You just have to put up with Josh Starmer's saying for the video clips, but if you can do that, the statistical and machine learning concepts are outstanding. So that's a really good statistics and machine learning range of videos. I think the video clips now almost 100, if not more. So it's a very, very large library of video clips. I promise you, if you just look at these video clips, your statistics knowledge will be in the top few percentile. That's how good these are. And then in a similar impressive fashion, 3 Blue 1 Brown, it's named after the progenitor's iris colors, is particularly good at explaining neural networks and convolutional neural networks. So if deep learning is kind of a mystery to you, despite reading books and articles, I highly recommend the 3 Blue, 1 Brown series on neural networks. It's really outstanding in terms of the animation. And I thought I understood convolutional neural networks until I saw this series. It totally puts you in a different level in terms of understanding. So I would recommend those highly. And obviously the books that I was privileged to be involved in, we're finishing up intelligence-based cardiology for those of you who are cardiologists. A few of you are actually authors also. We're also working next on intelligence-based primary care. I think primary care AI is so important yet under-leveraged, including pediatrics will be the next book. And then intelligence-based medicine has support from some of you already. It's a really good, I'm impressed with the overall quality of the manuscripts that have come in, and we're going over about 200 manuscripts in the last year or so. And thanks to all the reviewers' hard work, most of them are clinicians. It's really coming along very nicely. So that's a good sort of journal to kind of look into if you want to read what clinicians and data scientists are doing together. And then 3 sort of books in general on AI. And I always have the top 3 books that, again, they'll save you a lot of reading through a not so good book. So one of the highest recommendations from me is A Guide for Thinking Humans by Melanie Mitchell. She has the amazing ability to explain very technical things in very understandable terms. So that's a book I read cover to cover twice because it's that good. Genius Makers, it just came out this year. It's kind of a nice written history of AI behind the scenes to just make AI even more interesting. And the book I'm reading now is called The Ascent of Information, which just came out also. It's about why AI and algorithms are so important in our lives, not just in healthcare, but in our lives in general. So those 3 books I highly recommend. And then the ABAIM is the American Board of AI Medicine. It's actually, we're going to start calling an introductory course because it's not really a review. And we do it once a month. And you can register at abaim.org. And you basically come in at about 20–30% of knowledge if you measure it, and you end up with 70–80% in terms of knowing the answers to questions that we ask. So it's a really, really fast learning curve, rapid ascent on the learning curve, thanks to our amazing faculty. So that's a certificate program. And this is our core faculty. We also are blessed with usually 3 to 5 rotating faculty who are in the advisory group. So every course basically is different. We have people that come every 3 or 4 months because they just want to hear the same slides discussed different ways. And we're very blessed that we have the faculty that support that. So these are the 50 organizations that are represented that we have as part of our advisory group. So it's not a single university or single medical school generated course. It's really a multi-dimensional course based on all of our advisors. And some of the faculty are here. And then, so if you talk about degree programs, there's a growing list of now master's and PhD programs of AI in healthcare or machine learning in healthcare. When I was in school more than a decade ago, there weren't that many. Because of reputation, I went to Stanford, and it was much more about programming and statistics and machine learning than informatics. So they actually, while I was there, it used to be called biomedical informatics program, but they actually had to switch it to data science because it was much more data science than the typical informatics curriculum. In retrospect, I'm really glad because I much rather have had a strong data science background than informatics, which I think is just easier to learn on your own. So you're expected to know a lot of math, statistics, as well as computer science by the time you graduate. So it's a very, very productive, but very, very rigorous program. And the latest is that I'm the privileged convener along with Piyush and Matt Lundgren of the growing number of centers of AI in medicine. I'm proud to say that we started with 3, Stanford, Cleveland Clinic, and MI3 at Children's Hospital Orange County. Now we have close to 30 within just a few months. I imagine that in another year will be close to 100. So the number of centers that really focus on multi-dimensional AI projects is definitely growing. And it's important that we stay cohesive and learn from each other as well. So what do I see in the future? So Piyush asked me to make a few comments. I think AI in medicine education will be widespread. I'm already seeing that trend in university and medical schools. I'm privileged to be rewriting the school curriculum with at least one school, if not 3 in the near future. I think it will be a routine part of training programs. We're actually developing a rotation of not just informatics, but AI for our residents and fellows. And then I think health systems for clinicians will have regular CME activities that will be AI driven. And I think the ABAIM vision is to have a fellowship training and a board certification, not the educational certification, but board certification. And then of course, a few of us will be double boarded in informatics and AI, or in perhaps imaging and AI. So there'll be people with dual boards that will be part of the cohort of clinicians with an understanding of AI. So I think a very, very exciting future. I want to thank my MI3 Institute at Chalk, as well as my many good friends and colleagues at Stanford who continue to support me. This is our team. So for those of you who are interested in starting something at your hospital on your own, you definitely eventually will need a nice cohort of people to support you. And I'm lucky enough to have that. So with that, I'm going to give the virtual podium back to Piyush.
Yeah, thank you, Anthony. That was a pretty exhaustive list of resources to get either started or to get refreshed or to gain from. And it just amazes me how many of these organizations, you have helped start and lead, and how they are coming together with a common goal and a common agenda of advocating for AI in healthcare and educating clinicians and moving this forward. So thank you for that pretty exhaustive presentation. I hope everyone is able to gain something from that. We are all at different levels. We are all coming from different angles, but I'm sure we all have the opportunity to gain from the exhaustive list that you shared and the opportunities that you shared. Well, we'll take questions later towards the end. So with that, I'm going to invite Dr. Robert Hoyt. He is the honorary president and one of the founding members for the Medical Intelligence Society. And I've learned a lot from him, especially on the hands-on technical aspects. At the Medical Intelligence Society meetings that are done monthly, the ones that Dr. Anthony Chang talked about, he gives these snippets, he gives this brief advice on how to execute some of these technical issues, and they are extremely helpful and popular. Of course, he has extensive background in informatics, and he's also the author of one of the leading books in the same space. So with that, I'm going to invite Dr. Hoyt to talk about hands-on training, and what are some of the tools that are available to us out there.
Thanks, Piyush. Let me see. So the goal here is I'm going to talk a little bit more broadly. It would include AI, but it'll include a little bit more of data science and machine learning. But it'll dovetail pretty well, I think, with what Anthony has already covered. It's all about education and also about finding tools that you find useful. There are many journeys that people take either together or separately, and there's many ways to get there. Some people may be satisfied with exploratory data analysis, just cleaning up the data, preparing it, visualizing it, using some descriptive statistics. Other people may want to move on to predictive analytics, which usually means machine learning, to do supervised learning or unsupervised learning. Supervised learning is usually going to be classification or regression, depending on what your outcome is. But then many people will want to move on and do artificial intelligence or deep learning. And that, to some degree, these days is concentrated into two major areas: image recognition, largely with convolutional neural networks, and text mining, largely with transformers. But again, there are many ways to get there. I'm very much into beta testing any software or program or platform that comes out. And this just gives you an idea of some of the spheres of, and I've grouped these together, I hope logically. If you look at the stats packages, many of you, if you're in a large institution, have SAS or SPSS, but if you don't, they're very expensive. Well, Jamovi and JASP are free, open source, and excellent. JASP actually has some machine learning algorithms in addition to logistic regression, linear regression. In formal education, Anthony covered that to some degree. There are endless numbers of courses. Certainly Stanford has a lot of good courses, and there's a lot that's available to supplement your current knowledge. In terms of programming, that's sort of interesting. Most of us would say that busy clinicians probably have no business picking up or trying to learn Python or R. But what's happened is other things. That is, AutoML now is basically they have chained together multiple Python or R packages so that the amount of code you need to write is minimal. And I think we're moving in that direction. I put Auto AI up there. Nobody's using that term, but I'm going to. Check out a program called Ludwig that Uber, of all people, released open source. It requires only writing a script to do computer vision or to create a convolutional neural network using or using TensorFlow. And then Copilot is AI that writes code. You can get it to perform to try to write Python code. I would consider that alpha testing. In my opinion, it's not quite at the beta level. And then the next thing is what I call machine learning. You really could say data science platforms. You can obviously contract with a commercial entity like DataRobot, but I've checked all these out personally over time. These are all have a free version, as well as many of them have a commercial version, but they're a great way to start analyzing data. I'm going to concentrate on only one, Orange, which is so-called visual programming. The RapidMiner and NAME is how that's pronounced, also offer visual programming. Now, again, there are different avenues. A clinician who has domain knowledge but doesn't plan to learn a lot of data tools and concepts would be probably called a citizen data scientist or clinician data scientist. Or you can be formally trained as a data scientist, or where I'm spending my time is trying to develop hybrid clinicians that have the good domain knowledge, but are starting to pick up all these tools that are now affordable, intuitive, and now being able to crunch some numbers and report to a data science team and maybe a data scientist. But at least they have hands-on tools. And the one that I'm going to talk about is Orange. Now, a lot of people will go, Orange, never heard of it, can't be any good. That's sort of the initial response. But in point of fact, first of all, it's Python. You don't see it, but it's the computational engine. Second of all, it's free. It does data preparation, exploration, visualization, analysis. The analysis would be supervised and unsupervised learning. It does, in fact, do image recognition and text analytics, and it also has multiple add-ons to do other things. It was designed by guys that do computational biology, and others have gone to take advantage of this tool. It can be used in Windows, Macs, or Linux. It's used by multiple universities, including 2 US medical schools. And again, a lot of people said, well, never heard of that. But in point of fact, now I'm suddenly seeing it in the literature being used to analyze data and to be reported out. When you open it up, you'll see a menu on the left, and on the right will be a blank screen. You simply drag out what they call widgets, or operational, or operators rather. And so in this case, data sets, which has 65 data sets in it that you can use, that you don't have to upload anything. You drag out test and score, you connect some algorithms, different families, connect a confusion matrix and a ROC curve, and then this is what's generated over here on the right. To put together this group of widgets is less than 30 seconds. So under the data menu, it does a lot of things. The file widget is for data that you have, or if you have a URL, it will snatch data or scrape data from the URL. It does a lot of things. You can view, manipulate, merge. You can read this as well as I can, but it does a ton of things to your data to manipulate it and get it ready. If you have to have numerical data, like for unsupervised learning, it'll continuize the data. In other words, turn it from categorical data into numerical data. It'll handle outliers and impute data. So it does a lot. Visualize is fairly standard. It does distribution curves, box plots, violin curves, scatter plots, bar charts, and so forth. Here in the middle, you see a scatter plot with a regression curve. Below that, you see 2 box plots. As I recall, this is maximal heart rate on a treadmill. Number 1 is heart disease, 0 is no heart disease. And it conveniently gives you a student t-test to show you there's a difference in the mean that's statistically significant based on that P. So it's very user-friendly. And again, you just simply drag the widget out there and connect it. That's all you have to do. There's no programming. Here are the different models, and this is a little bit different. I think it offers more algorithms than most programs, other than some of the commercial ones, like, for instance, Data.Robot, which I think has 40 some. But in point of fact, these are the major families of algorithms. Almost nobody actually needs more than this. So again, you simply drop them over there. I've already talked about the ROC curve. And here in the lower left is an example of the test and score confusion matrix you've already seen. And then up here is a calibration curve, which a lot of people have not really seen, but yet the experts are asking for that along with the ROC curve. If you look at the predictions, and I don't have a good example of that, all that is let's say you're using logistic regression, and it's either going to try to give you the probability of it belonging to class 1 or 0. And so what if instead of 1, it's 0.9 or 0.7 or 0.8, and instead of 0, it's 0.15 or 0.2? Well, if every single patient, if we're talking about medical data, has that kind of probability, you can create this curve, and it ought to be at a 45-degree angle. This is a good calibration curve, but that's done again in seconds and is very desirable if you're going to publish a paper. Unsupervised learning, the only ones I've used is this is hierarchical clustering over here. This is the famous iris data set where there's 3 different iris species. It just divides it that way. And this is a scatter plot of the clusters with k-means clustering. And it does principal component analysis and a lot of other stuff that I really am not familiar with and have not used and is not mainstream. Image analytics, I started playing with this, trying to see how good it is. It uses 4 different CNNs. This one is Google Inception version 3, which I think is 100 hidden layers. As an image viewer, I'll show you in a second. And remember, most of deep learning is really classification or supervised learning. You have labeled data, labeled melanoma or labeled basal cell epithelioma. So you want to try to classify it and see how well it does. This is an example of what you see in the image viewer. So you can kind of go back and check, yeah, that's what I uploaded, that's what I want. Here is the confusion matrix. I think this was for logistic regression. And the model performance is logistic regression and random forest. But again, so I was able to do this in about 30 seconds. All you have to have is 2 folders of images, one for melanoma, one for BCE. Very user-friendly. Text mining does a lot of different things. On the left, it has different corpora. It has PubMed. It has New York Times, Wikipedia, and Twitter. If you want to start trying to do natural language processing, I'm doing kind of an easy one here, but I went into PubMed and my search term was long COVID. There's a lot of other terms that mean those people that have prolonged course. I said I wanted 758 abstracts with an article title that's there over here in the middle. And all I did is I pre-processed the text to get rid of the stock words like the and did a few other things to get it ready, and then simply did a word cloud. That's not very sophisticated, but for purposes of this presentation, just to show you how simple the workflow is to create that. So it has a lot of YouTube videos that are 3 to 5 minutes, which people seem to like these days. Each widget has a help library and an example. Very easy to run both the train and test data. I've only shown you training data. You just use a widget and you split it. And the other thing that's unique is that you can run multiple algorithms at the same time, so you compare models. Many of the programs make you run the algorithms individually, so they're not as user-friendly. And also the widgets are interactive. So for instance, the confusion matrix, if you say, well, I'm interested in the false positives, I want to know who they are, what they represent. You just click on that, highlight it, and connect it to a data table or a visualization, and you find out exactly who those people are. The data science workshop that we're delivering as a feature of the Medical Intelligence Society, sponsored by me and Anthony Chang, uses Orange. Why? Because of all the different platforms I looked at, this is the most user-friendly by far. The course itself, the curriculum, in other words, is on myicourse.com. That's free. You can go there, sign up, and take a look at the data science course. I also put the curriculum together in an ebook. The sessions are recorded. The next one is December 4th. We're going to start on unsupervised learning. Again, every month for about 1 hour. The details are on the Medical Informatics Society website. I've expanded it even further since September, adding a bunch of modules on evidence-based ML and AI, which help people trying to interpret the literature, time series, geocoding, and databases to teach basic SQL or SQL commands. So in conclusions, I'm only talking about one tool. I have tons of other tools, but this is just one. Programming expertise is difficult, and believe me, I've done it with Python. And so for the average clinician, it's a steep climb. But Orange makes that very doable. But AutoML may change that over the next several years. I always recommend that people try several data science tools and report them out. If you have a data scientist and you come up with some conclusions on the data, show that to your data scientist. If you're looking for additional data sets, the medical ones that I use for training, for education, they're on my website where my books are. If you have any questions or you're interested in the website, or rather the workshop, please email me at my email on Gmail. I'll go ahead and stop the share and entertain questions later.
Oh, that was a great presentation. I would say, like, Bob has the art and the skill of making difficult technical stuff look really easy. So thank you for all the work that you do. It's a lot of work to go through a lot of these different tools that are there, but you synthesize that and you are able to showcase, what's useful to all of us and how to use them and implement them. Again, the Medical Intelligence Society, their workshops and their monthly sessions where Bob talks about some of these tools and gives us these snippets of advice. They're extremely helpful. So I would encourage you to join us, register for those, go to the Medical Intelligence Society website. It's very easy to register for these, and you can get all the information and stay updated. With that, I think I'm going to introduce a couple of other speakers here. One is Dr. John Lee. John Lee is an emergency medicine physician. He's also the Chief Informatics Officer for Allegheny General Health System. He is the vice president for the Medical Intelligence Society and has an extensive background in informatics and AI, and has been leading a lot of efforts across the country in this space. And our other speaker is Dr. Hoang Nyugen. He is a pediatric cardiologist, electrophysiologist out at UT Southwestern at Dallas. He's the current treasurer of the Medical Intelligence Society, and again has been supporting a lot of efforts in this space. So the first question I have is for John. John, tell us about your journey. Talk to us about your journey, and especially in relationship with informatics, because that's, people think if you do informatics, you're doing AI. Is that true?
So my journey started out very similar to yours. And in fact, the AI Med conference that I first went to may have been, I think it was probably the same first one that you went to, and that's where we first met up. And one of the things, and this actually dovetails into your other question, in that what became apparent to me and why I became so passionate about this is that I started looking at all of these tools, and I realized this is actually the same thing that I'm doing in informatics, just with a lot more data, a lot more sophistication, and a lot more computational power. So an example that I often use is I'm an ER doc, and we use something called a heart score to do some sort of crude calculation as to whether a patient is at high, moderate, or low risk for an acute cardiac event in the ED over the next month. And that helps us determine, hey, I can send this patient home. But what people, if you're dogmatic about this quite well validated through multiple studies tool, it only has like 4 different things that determine the score. But if I've on multiple occasions had someone who scored high risk, but then another feature was not included in that score. And like for instance, they scored high, but they just had a cath 2 days ago, and so I can send them home because they had a clean cath. That's not part of the score. And that sort of mental calculation is something that we do on an ongoing basis, just as clinicians, and we try to meld that into informatics. And what artificial intelligence does, it allows us to do that at scale, at speed, and incorporate all sorts of other pieces of data that we would not necessarily even consider. And so it's just, to me, it's just a natural extension of informatics. And to what Anthony talked about, it's a natural extension of how we train our upcoming medical students. I fully envision that artificial intelligence will be, and data science tools will be part of the curriculum. And I still kick myself now for really not paying attention to the statistics part of to the medical curriculum, because it was just, the difference is that those statistics classes that we took in medical school were all about, taking a look at medical studies and being able to intelligently ingest this information in those from the file cabinets of papers that you all collected back in decades ago. But the difference now is that these tools are things that you have to know about and will have to know about as a physician going forward. Because if you don't understand, like if I'm an ER doc and ultrasound is becoming really prevalent in the ER, if I don't know some of the physics behind why gas in the belly looks like a black blob, then I can't make those sorts of connections. So you don't have to become a data scientist. You don't have to be a programmer, but you have to understand the tools. And it's that sort of connection that I'm so passionate about, because that's essentially what clinical informatics is. It's connecting computational and data and information systems capabilities with the clinical and operational goals of what our colleagues want to accomplish. And that's my story. You're on mute.
Oh, thank you. Thanks for pointing that out. But a follow-up to that is, do you think the current informatics training curriculums, or whether you do a fellowship or some other things, are designed to fulfill the needs for training in machine learning or AI, or are they evolving towards that? Because a lot of people think that, you know, like to get trained in machine learning or AI, you actually need to take one of these informatics courses. But I think that's
ideally I mean, just to give you even a simple example of some of the where these things are kind of lacking. I talked about not paying attention to statistics in medical school. I had to reteach myself statistics after actually I got board certified in informatics. So I was able to skate through, but not really know that much about statistics, and had to kind of relearn it all over again. So to answer your question, that hole needs to be filled. And quite frankly, I think it needs to be a core competency.
That's great. Well, I'm going
to. And as another simple example, I know plenty of informaticists that I talk to who don't even know how to use a pivot table. So, you know, that's where some of the gaps I think need to be filled.
That's great insight. Hoang, I had a question for you. How about your journey? So I see a lot of parallels between, you know, yourself and Dr. Chang and you evolving, you know, into all these different roles, both having common grounds as like the cardiologist. Talk to us about your journey and how you got into that. What are some of the pathways you took to learn more about machine learning or AI?
Yeah, thanks, Piyush. I think, you know, our journeys kind of mirror each other, you know, among Dr. Chang, Dr. Lee's, Bob, and yourself, and I think we can all trace our lineage back to that first AI Med, you know, conference. So I think my first interest was rooted in doing clinical research, and you know, like classical, so to speak, statistics. And then, you know, came along this kind of these new tools and areas that offer kind of more insight or a different way or a novel way of doing things. And that's how I got started in getting interested in that. And the more I got interested in that, I think the more I kind of wanted to have a more formal training in it. And so I think my journey has gone through and currently still going through all those three kind of resources or big categories of resources that Dr. Chang has mentioned. I got an analytics, you know, formal training in analytics, which is those tools, but geared primarily towards business. And so then while I have that kind of very basic understanding of the basis of these tools, then I had to kind of learn on the fly with you know, online courses and spot learn these techniques in applying them to healthcare questions and healthcare problems. And then of course the refresher or the kind of continual updating through conferences, you know, both through AI Med and MIS and the ABAIM certification courses. And so that's kind of the journey, but from a kind of theoretical standpoint of it. And so then how to stay relevant and practice these skills is also an ongoing endeavor to actually kind of shift your role in terms of knowing how to kind of program into a more kind of clinician role in terms of working with a team, and you don't necessarily need to know how to program but communicate the clinical questions, the relevant clinical questions, and being able to evaluate or communicate the need for the programmer or for the data scientist and evaluate the work and troubleshooting most of the time along the way to kind of bring those two domains together. So I see my role as evolving as that person, and that also requires lots of practice and practical projects to stay relevant and evolve in that role.
Yeah, that's a great point. I think what I've learned over the recent past is that many people think like, okay, I need to learn AI, and they think it's a one-time thing. But I think we have all learned that it's not a one-time thing. It's actually a pretty significant commitment, because the tools that we used 2 to 3 years ago, probably we are not even using them now. And the AI itself has evolved so much. The science of that has evolved so much that to keep pace with that, you have to make that commitment. That is what you're making. And I think that is what I understood from what you said too. But I think that there are always these questions for clinicians, like, do I need to program? Do I need to learn programming? And I just want to get take. Of course, Bob illustrated that there are some easy auto AI or auto ML tools that are there. But I just want to get your take on that. That do you need to learn programming, or is that an essential component of that, or what do you think is the most important component of learning? Maybe you can start with Dr. Chang, and we are all blaming him for getting us started with this. So you did start the fire in California, but what are your thoughts on that?
Yeah, my Stanford mentors will have to cover their ears, but I don't think it's the most important thing you do if you're interested in this space. I think it's a new tool. If you really have an innate interest, or you're like me, you just kind of want to learn what the other side sees. Most people don't find that, burning desire to do that. I kind of like to see dual perspective, just like I was trained as a cardiologist and intensivist. I like having that sort of dual perspective, but only if you have that innate interest and the yearn for a dual perspective do you really need to learn programming at a level where you could be doing projects and sort of studies. If you don't have that burning desire to do that, then I think you're perfectly situated to use your clinical knowledge and insight and work with a data scientist side by side and come up with some amazing projects. And I've seen clinicians with virtually no programming skills as co-author in a paper that is just outstanding. So my answer is no, you don't need to learn programming. And that also should not be the first thing you do. It should be just learning about the applications and the limitations of AI, and just have a general sort of working knowledge of artificial intelligence beyond just machine and deep learning, because there's so many other branches of AI as well.
Yeah, great thoughts. Bob, what do you think? Like, with all the auto ML and auto AI techniques, how much programming background do we really need as clinicians to get started in this, or do we even need it?
Well, it's kind of interesting. I sort of see 3 stages of programming, and I'll just use Python because that's what I'm familiar with. You might take a course in Python for 3 or 4 or 5 months before you ever get to anything that you could apply in a meaningful way. And then you go on to actually do intermediate, to do data science things of data preparation and cleaning it up and maybe doing a little bit of supervised learning. And then ultimately, if you want to do deep learning and use TensorFlow and Keras, that is a totally different tall mountain to climb. And that's what I find discouraging. So my answer to you is, I don't see any average clinician, even with some programming experience, in learning a language like Python in order to do deep learning. Now, to use AutoML for basic data science functions, yeah, I can see that. But in general, no, I think their time would be spent better elsewhere.
Great, yeah, great thoughts. John, you mentioned the statistics part of this. I'm going to get a take from you on that. So clearly, like programming is not necessarily a starting point, but how important is it to understand the statistics or the methods part of machine learning or AI, and how you're using the accuracy parameters? How important is it for us to understand, especially in context of increasing number of publications? You know, there are so many publications there, and they are using different statistical methods than our traditional p-values. So how important has it been in your experience to understand the math behind this?
Well, you don't have to understand the granularity of the math, but you have to understand the principles. And I would highly suggest the ABAIM course. I thought it was fantastic. It was a great introduction for anybody who's wondering, what is this all about? What does it look like when you pull back the curtain and see the great Oz pulling all the levers? And this actually touches base with the question that Ashish noted in the chat, that when I started out in informatics, it was just a start. And similarly, when you start out doing this artificial intelligence and data science work, you have to start somewhere. And this stuff is moving so quickly that you will constantly be in a state of learning. And in my position as an informaticist, I find that I don't have to, I realize that I don't have to know how to program, but I do have to know some of the basic underpinnings of why certain things are so important. And in particular, one of the things that has really come home to roost in my head because of all the stuff that I'm digging into is just the concept of cleaning data and data hygiene. And that's something that I actually absolutely can influence, because I can help control that ecosystem of data upon which all of these tools are dependent upon. So did I answer your question? I'm sorry. It is really important. And it's interesting. One of the things that I recall is that when I first started this journey, people were talking about like linear algebra and vectors and all that, and it just kind of said, well, that doesn't, well, that like, I don't know. And then once I started actually learning about some of the underpinnings, and it just made total sense, started making total sense to me, and understanding why that particular piece of math, as opposed to say calculus, is so much more important, and understanding how that then connects up to clean data and all sorts of other things. So that, yes, you do need to know about that sort of stuff, but you don't need to be a programmer.
Yeah, that's great. I think you answered two questions. You answered my question and Ashish's question in one go. That's a great skill set to have. I think, Junaid, thank you for sharing a lot of resources and your comments here, but I think we're about time. So I'm going to ask my last question for wrap up from each of the speakers here. If you had to start today, because we all started our journey at different points in time, where would you start? So Anthony, you can't say from AI Med because you started that. So where would you start?
If I had to start from scratch today, right now.
Yeah. Where would you start from?
I
was just kidding about AI, but I think that's the best place to start.
I would start getting to know clinicians that are in the space, so you know exactly what the range is. I think most of, just like data science, if you don't know what the range is, you're going to start from the very beginning and learn Python or learn R, and maybe that's not the best place to start. So I would talk to 10 to 20 different clinicians, like the ones that are here, and get that range defined for yourself. And then in that range, find what your personal journey is going to be. And it could be anything from just starting to come to meetings like this and get involved with a project, to going to school and getting a PhD in data science. And that's a very wide range. And I think it's a very, very personal set of decisions.
Yeah, and I would highly recommend your book, the medical intelligence one. I think that's a great one, very comprehensive, but keeps it very simple to help you understand what AI in healthcare is all about. Bob, what about your thoughts on where would you get started from today?
Yeah, well, I would agree with Anthony that the end goal is mainly AI, then do it that way. I guess I view it a little bit different. I view AI as being part of data science. Therefore, I probably the first stepping stone for me would be data exploration, preparation, cleaning, all the basics, including some real simple statistics. And then I move up the ladder to machine learning, then on to AI. So maybe I'm biting off more than I really should be, but I would start simple that way, getting to know the data and being good at exploring and visualizing it.
I would absolutely agree with that. And as clinicians, always don't get so so caught up in the rabbit hole of the math. Your real value is that because you take care of patients, you can understand those connections. And that's, I guess that's me speaking from my bias as a clinical informatics person. If you can make those connections and understand that there are certain things that you can do to help make those connections between the math and what you're trying to solve with the math, that's extremely valuable.
Yeah, and I meant to sort of add the comment, though, that even with deep learning, you still need to understand sensitivity, specificity, accuracy, AUC, all the performance measures, because they'll try to pull a fast one on you on the articles. I'm going to report one for the MIS that instead of using an F1 score, they used an F2 score, because it looked better than F1. But the point is knowing that kind of stuff and be able to navigate your way around there. As a clinician, they're going to ask you, the data scientist is going to ask you, well, is it more important to have sensitivity or recall or precision or specificity? And as clinician, you need to decide that. So that's, again, I think, very important.
Hoang, what about you?
So I think it depends on your, I think it's born out of necessity, or it depends on your context. But I think it would start out as clinicians would start out from the back end or from the problem. It's your clinical questions or your projects or research questions, and then branch out from there, and learn along the way to kind of plug holes. And it's not and then learn things along the way, depending on who you talk to and what the literature has performed, and kind of learn by mirroring or by imitations for a little bit. And then once you have a certain amount of knowledge, then continue to build from there. And so that's what I've done, and whether or not you have a supporting cast as well. Okay, so when I had to learn statistics through YouTube videos and that it's because of born out of necessity, and I think that is a great way, or a great driver to kind of keep you going.
Well, I think we are lucky that we have people like yourself who spend so much time and effort in putting all these resources together for everyone. And when we started, there was AI Med, and now we have so many other resources that have blossomed, whether it's Medical Intelligence Society, or as Junaid highly recommended, the ABAIM course, or these monthly sessions that are there with Bob. I think there are so many resources. We're truly blessed, and thanks for all your efforts in promoting education related to AI and helping clinicians evolve in this field. And again, please go to the BrainX Community webpage. You'll find the upcoming meetings. Please try to connect with us on December 13th for the MIS monthly meeting. And then in January 2022, the in-person meeting for us for the AI Med. That is another great avenue to get started with your New Year resolutions and start making a plan for the next year. And then mid-year, we will test you whether you kept your resolutions or not at the Medical Intelligence Society Annual Summit. That's going to be in July. I have the date as 29th and 30th. So stay updated, stay connected with us, and continue with your learning journey. Thank you, everyone. Thank you, Anthony, John, Hoang, and Bob, for your great advice. And thank you, everyone, for joining us and your participation. Until next time, take care.
Thanks so much.
Thank you.
Bye.
Bye.